Okay, so we'll begin by having a look at a question from yesterday. This is page 117, number 3. It was assigned yesterday, for those of you that may not have been here. The question reads, the Stanford-Binet IQ scores of Canadians are normally distributed to a mean of 100 and a standard deviation of 16. So what does that mean? Well, it means that the average Canadian has an IQ of 100, and approximately half the population has a score greater than 100, and approximately half the population has a score less than 100, I guess, right? And the standard deviation is 16. So according to this test, what is the probability that a randomly selected Canadian will have the following IQ? So how do you do that? Well, the first thing you need to do is you need to draw that curve. What would you call that curve? Remember yesterday? Bell curve or normal curve? Okay, bell curve or normal curve. And when we say that the mean is 100, we show that by putting a line down the middle and labeling it 100, right? That's the mean. So a standard deviation of 16. The next step would be to sort of mark bars on either side, and that's at plus or minus 1 standard deviation. So if I go up, this is 100 plus 1 standard deviation, so 100 plus 16 is obviously going to be 116, right? And if I subtract 16 from the other side, 100 minus 16, that's going to be 184, right? Everybody nod. Oh, just checking. 84, Kiefer, yeah? What would be the next boundaries there, Kiefer? I'll give you the easy one. 132. And I'll see if I can do this one right. What's that going to be? 70, 60, 68? All right. Okay. Now, what about the numbers across the top? Do they always stay the same? They do, right? So this one here is 34. This one here is also 34. But you're actually supposed to go see Mr. Alf right away. Yes. Are you planning to? Okay, so we got 34% either side. Do you remember what the next numbers are, Lacey? Do you remember, or you can probably find it quick in your book? Is it 13.5, right? And 13.5 here. So now the first question, less than 100. Well, I can actually do this without doing any adding. What percent of people are going to have a score of less than 100? 50. Exactly 50. Exactly. So part A is exactly 50%. Half of the people are going to be below average, Brandon. Below average. Seems a little harsh, don't you think? No, just below. Let's just leave it as below an average score.
How do you know if you want to go down farther, like the 2.35 numbers at the top?
Well, that was just less than 100, right? So let's do the next one here. B, an IQ of less than 116. So less than 116 is basically everybody here plus these guys, right? So that's going to be 50%, which we're below, plus another 34, which is 84%. 84% is below 116. Greater than 116? That would be the opposite of that, right? So what would be greater than 116? Well, that would just be the remainder, right? If 84% are below, then what percent is above? 16%, right? 84 plus 16 is 100, right? Does that make sense, Janelle? The other half? The other side? Not the other half. The other side. What about the last one? Between 84 and 116. Oh, this is actually pretty. Between 84 and 116 is going to be 34 and 34? 68%, right? Okay, so that's what we did yesterday. Now, I left you with, what do we do if the numbers, like what if I wanted, say, between 80 and 120? How are you going to do that? You can't. So that's what we're going to look at today. So this is on page 119 in your book. This is tutorial 3.4. This is what we call the standard normal distribution. Same principle, same concept. We're just going to expand a little bit. In the textbook, Luke, page 119. And you should have got a handout there. Mr. Smells, here, right here. Yeah, are you going to join us today, Bobby, or are you going to sleep with us?
No, Bobby, you can't just do this. No, you can't just keep doing that.
I don't know. You know what I did once? Enough stories from the past. We'll do it on Saturday. What are the chances Saturday constant? Pretty much none.
And
Yeah.
Yeah.
Yeah, exactly. In tutorial 3.3, they used the normal distribution to calculate probabilities. In each problem, the normal distribution had a different mean and standard deviation. We could only calculate probabilities with data values that were exactly 1, 2, or 3 standard deviations away from mean. We could only do it when the numbers were exactly on these values. In this tutorial, we will introduce the standard normal distribution that can be used in every problem for any data values. In other words, you can throw in everything that I showed you yesterday because this is really how you're going to have to do it.
Jesus.
Okay, but it's sort of just expanding it, just building blocks.
So what we did yesterday, just forget about it.
Well, not entirely, but what I'm going to show you today will solve the problems that I assigned yesterday.
What did they question on the test, like the one that was?
Do it that way. You could do it easier that way. If you learn how to do it the correct way, it might take you a few more seconds, but the principles are the same. The principles are the same.
Now, just a little off topic. There's no school this Friday.
Correct.
Sorry for interrupting.
No problem. No school Friday. The standard normal distribution is a normal distribution that has a mean of 0 and a standard deviation of 1. So you'll notice here on this first sheet that I just handed out to you, you'll notice that the mean is right at 0, and the standard deviation marks are labeled 1, 2, and 3, and -1, -2, and -3. Quick question, or quick point, it actually goes beyond 3s. It can go to 4, 5, and 6, and 7, and 8. 3 is sort of the usual limit. Brad? I suppose. Yeah. All right. So the standard normal distribution has a mean of 0 and a standard deviation of 1. It has the same properties as any other normal distribution, and it follows the 68, 95, 99% rule. In other words, 68% of all scores are within one standard deviation between -1 and +1. 95% of all standard deviation is between -2 and +2. And 99.7 is between -3 and +3. So there is actually a small 0.3% that is bigger than 3 and less than 3, but it's so small that we generally just sort of ignore it. Okay, at the bottom there, on page 119, when we use the standard normal distribution, we use the letter Z to represent the numbers along the horizontal axis. The values of Z, called Z-scores, represent the number of standard deviations from the mean. These are referred to down here as a Z-score. A Z-score. And it simply means how many standard deviations from the mean. Okay, so if, for example, you did an IQ test and you rated at a standard deviation of your Z-score was +2.5, you would be way up here. What does that mean in terms of your intelligence? You're way above average. Way, way, way above average. Okay? In fact, most people, way more than 58%, way more than 50% is below you. Okay? So a Z-score of plus means above the average. A Z-score of minus means below average. All right, flip the page. Page 120. To calculate the Z-score, subtract the mean from the given value, and then divide by the standard deviation. So the formula that we use, and you're going to need this on your cheat sheet, is Z equals X minus mu all over sigma. That's the formula that you need to calculate the Z-score. Write that down. Even if you're lazy, you need to write that down. I'll explain. I haven't explained what they all three of them mean. Actually, I know you're extra paying attention. The Z refers to the Z-score. The X refers to what I call the raw score. So Z is Z-score. X is referred to as the raw score. The mu is the mean, and the sigma is the standard deviation. Okay? So when you normalize a raw score what you do is you compare it to the mean. It's sort of the same kind of thing as if you have a test and you get, say, 22 out of 29, and on another test you get, say, 23 out of 31, which one did you do better on? 22 out of 29 or 23 out of 31? Which one's better? They're pretty close, aren't they? How do you figure out which one's better? What does that mean, divide? Yeah, you divide the top and the bottom and you convert it to a what?
That's a decimal. Percent.
A percent.
Well, yeah, you can keep it as a decimal.
Well, you could, but you're basically converting it to a percent, which is a way that you can compare two things that are not the same. It's sort of a way to compare apples and oranges.
You sure you don't want to change it?
Thanks, Matt. Yeah. Thank you. Go ahead.
Anybody else? Like, come grab one. Bobby, come grab one.
Keeps Bob awake, then I'm good with that.
Barbecue sauce?
Okay.
Salad?
Okay, so converting to z-scores is a way of comparing two different things that are different. It's sort of like converting them to percents. Okay, let me explain with an example. So, reading page 120, converting data to z-scores allows us to calculate probabilities for data values that are not exactly 1, 2, or 3 standard deviations in the mean, and to compare data from different distributions. In the example in tutorial 3.3, we assumed the data about the actual masses of 43-gram bags of Cadbury mini eggs were distributed early, and the mean mass was 43.86 with a standard deviation of 0.76. So you have this chart right there, right? Right? Got that chart? Okay. So we can use these data to estimate the probability that a randomly selected bag will have a mass of less than 43. So here it is here. Based on what I told you yesterday, you can't calculate the shaded value. This is at, this is the mu right here. This is -1 standard deviation. This is -2 standard deviations. You can't calculate that because you don't know what percents to add together, do you? Okay, so the way to do that is to convert it to a z-score. So in this case here, my 43 is referred to as my raw score. The 43 is the raw score. It's the number before normalizing it, before converting to a z-score. So step number 1, write it as a z-score. So you're going to write z equals x minus mu all over sigma. Okay, the x value is the 43. The average was 43.86. And the standard deviation was 0.76. Now, if you were doing this on a calculator, you have to be very careful. You have to make sure you do the subtraction before you do the division. The best way to make sure that happens is to go 43 minus 43.86 equals, and then divide. If you want, you could just use brackets. Okay? But I'm hoping you can see 43 minus 43.86 is going to be what? Minus 0.86 all over 0.76, right? And you should get a z-score of minus 1.13. Does that match with what the picture shows? Does it match with what the picture shows?
Yeah.
Yeah, because this one right here is at 0, right? This one here is at -1. This one is -2. It's just below -1. It's minus 1.13. Okay? Nod and say, yeah, I'm good with that so far. Yeah, Jerome? Okay. The z-score should always be between about -3 and about +3. What do you do if you get a z-score of about 4? It's okay, it's just not likely. If you get a z-score of 17, probably did something wrong. Okay? Brett, what are the z-scores between? What are the z-scores between? I mean, like, what two numbers should the z-scores be between? Like 0 and 1, or
That one?
any time? Rowan?
I don't get the question.
What two numbers should the z-scores be between?
-3.
-3 and +3, good. Yeah.
How do you get the raw score? You just kind of take like a...
No, it's the question. The question says on page 120, The question says, we can use this data to estimate the probability that a randomly selected bag of Cabernet eggs will have a mass less than 43.
So tell you that
It has to tell you that in the question. It has to. Okay, so in other words, just roughly, Lacey, what percent is less than 43%? Just rough, ballpark. 3%? That seems a little low. No idea? Okay, what percent would be less than 43.86? Okay. Rowan, do you know what percent would be less than 43.86? No, what percent? Don't know? 50%? No, exactly. Were you thinking that, Lacey, and you just didn't know for sure? No. 50% are less than the average, right? The shaded area refers to that percent. What's the total shaded area in percent? 100. So half of it is going to be 50%. So I'm going to ask you again, Lacey. If half, no, you can do it now. I'll phrase it so you can get it. If from there to the left is 50%, what percent is actually shaded here? 40? Would you say that bit right there is only 10% of all that stuff? That seems like an awful lot of white space, no? Like it has to be less than 50, right? All of this is 50, about 25% or so? Maybe even probably less because this is pretty high here, right? Okay. 25 or less. Certainly less than 25. Okay, so how do we do it? So what you do is you have to convert this minus 1.3, you have to convert to a percent. Now, if it was right on that, we would just add up those numbers on top. We don't have that ability anymore. We have to use our graphing calculator. We're going to convert minus 1.13 to a percent. So to convert to a percent, very, very simple. Okay? Second function, distribution. I like to use the drawing version of it. Second function, distribution, and you're going to pick shade norm. Shade norm means draw me a shaded area under a normal curve. So shade norm. Now, I have to give two things to shade norm. I have to give it an area to shade from here to there. I sound like Dr. Seuss. Okay? I need to tell it how to shade from way down here to way up here. Okay? So I'm going to go shade norm bracket. Now, what did I say the smallest x or smallest z score was?
4.
Close.
Good shot, Dylan.
It's negative.
-1.1.
No, the smallest z score. I said -3. Now I did point out that there actually is a small percent that is beyond -3. So to sort of take care of that, I like to go down to -5. If you put -6, you're going to get the same thing.
Okay.
It's such a small difference. So -5 is usually good enough. So we're going to shade all the way from -5, which is way out here, all the way up to this value right here. You have to put a comma, yes. Now, what's this z score that we're shading up to?
1.
-1.13. Okay, so on your graphing calculator, you're going to go shade norm -5, comma, -1.13. It's like a boundary thing. You're shading from -5 all the way to -1.13. Okay, press enter. I get an invalid dim. Well, let's just quit.
Apparently I don't.
Good for you.
I don't.
Invalid dim means you've got something that is trying to plot that it can't. Now, I likely know what's going on here. I'm going to guess that I've got a stat plot turned on, so I'm going to go second. I'm going to go to my go-to. Go down to press enter. Yeah, it doesn't like this. I'm going to go second function stat plot. Notice that I've got plot number 1 is on, and it's trying to plot L1 and L2. And I'm guessing L1 and L2, I don't have anything in L2. So it's trying to plot something that's not there. So I'm going to have to try to turn that stat plot off. Let's do that. Second function, y equals. Press enter and change to off. Second y equals. So turn off your stat plots. Okay. Now let's try my shade norm. And I get some crazy looking thing.
Oh, you have to set up window settings.
Roland is right. The window settings are on. Now, the good news is that the window settings are always going to be the same for this Roland. So that's good news. You don't have to try to figure it out every time. It's always going to be the same. You might even want to write it down so you've always got it. I'll give you the window settings. The window. Now, we've already done the shade norm. I told you that the smallest Z-score is a 3. Are you trying to do a shade norm on your iPhone, Bob? Because there probably is an app for that, but I'm guessing you don't have it. Oh, you will be unsuccessful. Very unsuccessful. So the smallest value of Z-score is -5. The biggest value of Z-score is +5. So we're going to change my X min and max to -5 and +5.
I have plot stat stuff in my windows.
Oh yeah? Press window. Did you press window?
Yeah.
Yes, I do. So -5 to +5, y min -0.2, y max 0.5. The good news is you can either write them down because they're always going to be the same, or the other thing you can do is you can actually store that into memory. So I'm going to show you how to do that. If you want to store it into memory, you simply go zoom, memory, store, number 2. And it takes that window and it puts it into memory. And if you want to bring it back, it's pretty easy. You just go zoom, memory, pick the third one, zoom, recall.
Why does mine look different?
Now, unfortunately, the shade norm feature doesn't, when you change the window, it sort of clears it. So you have to do your window first and then do your shade norm. So I've got my window set.
Why do we set a window up?
What I just told you. The -5 to 5, -0.2 to 0.5. Okay, and now I'm going to have to do my shade norm again. So, second function, distribution, draw, shade norm, -5, comma, -1.13.
That is good.
And now you're going to get a beautiful looking graph. Does that look like the picture in the textbook?
Yeah.
Pretty darn close. Pretty darn close. This area value, this 0.129, guess what that is? That's the number we're looking for. That's the percent we're looking for. Okay? That's what we are indeed trying to figure out. Okay, so I'm just going to put that in there. Give me a second here. What I want to do now that I've showed you that whole question is I want to go back to the start and I want to show you the steps. I would recommend you write down the steps that we just went through. Okay? Here's how to do that question once again. So back to the start. The question was, what percent of Cadbury mini eggs are less than 43 grams? That's what the question was. What percent of Cadbury mini eggs are less than 43 grams? So step number 1, what did I do first? I converted to a, what's the -1.13 column? What's the step number 1? I converted to a Z-score.
That was great.
Step number 1, convert to a Z-score. I'm looking around to see who's going to write down the steps. Convert to a Z-score. Brandon. Convert to a Z-score was step number 1 by using the x minus mu all over sigma formula. Okay? Convert to a Z-score. Second step, set your window up. Is the window settings always going to be the same? Yes.
Why?
Because it's a standard window. It's always from -5 to +5. And that curve never goes above 0.5. It's going to be the same. The window is always the same. That's the beauty of the standard normal curve. Okay? So set up your window. Now, how do you decide what these shade norm things? Shade norm always works from left to right. So you pick the smallest z-score that you have to shade from. Okay? You really should draw this picture too when you're doing these questions. Because I'm shading this area here, what's the left boundary? How far down does it go? -5. So I'm shading from -5 all the way from left to right to -1.13. I have to shade that region from -5 to -1.13. So I type in shade norm -5 -1.13.
How do the 1.13?
Because when I converted my raw score to a z-score, that's what I got -1.13. That's the furthest right that I have to color.
It doesn't look like 1.13 on the picture.
Well, remember this is 0.
Yeah.
This is -1, so it's just a. Or you're saying on here? You're saying on the here? Well, see that little tick mark right there? That's -1.
I can't see that.
You can't see that? There's a little tick mark here. Let me pull it down real for you. There's a tick mark right there. So it's just to the left.
Okay.
Okay? You'll have to take my word for it. Okay, so I'm going to give you another question to do. You're going to try this. Here it is right here. Okay, here's the question I want you to do. What percent of Cadbury mini egg bags are greater than 48 grams?
A bunch.
What percent
I tried right now.
are greater than 48 grams? Give that a whirl. Follow the steps. Sorry, I screwed up. I made it up on the fly.
It's okay, man.
I'll fix it. 45 grams.
That's not this stuff.
It's exactly what we just did.
I know, but you have extra charts.
Yeah, you have extra charts there. Okay, what's step 1?
Would it be -5 or +5?
Convert to z-score.
That's where it was.
Step number 1, convert to z-score. What's the formula? Z equals x minus mu all over sigma.
All over sigma.
All over sigma. What's the x value? The raw score. In this case, it's
Oh, that's right.
45. So 45 minus my mu, which is 43.86, all over the standard deviation, which is 0.76. In other words, how many standard deviations is it above the mean?
What is 7/6? How did you get the standard?
Right there. It's right there. It's going to be given to you in a question. Okay, so I go to my calculator. Go to my calculator. Watch, you guys. I go 45 minus 43.86, right? So I'm above average. I divide by my standard deviation of 0.76. I get a z-score of 1.5.
Right, okay.
Excellent.
Excellent.
Which means, what does that mean if you're at a z-score of 1.5? It means it's well above average, keeper. Well above average, 1.5. Well above average.
Then we take that shade
Okay,
down.
so that's going to be like right about there. Now, if I'm going greater than 45, Bobby, do I shade to the left or do I shade to the right?
Right. Sorry.
Dylan says to the right. Do you agree with him?
You.
How come? Because it says above 45. Which way are the numbers bigger than 45? To the right.
What's the shade from that?
So to the right. So what is the smallest z-score? I start from the left. 1.5 is my smallest z-score. And I go all the way to the right to
46.
+5. Z-scores. 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 All the way from 1.5 to +5.
Bam.
So
For
I
some reason, my graph still shows my others. Then.
yes, now it does still do that actually. I'm glad you brought that up because the graphing calculator wasn't programmed very well. You actually have to clear the drawing area first. So I'm glad Brett brought that up. Before you do this next step, you actually have to clear the drawing window. So to do that, you're going to go second function, draw, and then it's pretty simple. It's the first one, clear draw. So second function, draw, clear draw. Press enter. Okay, that sort of erases everything. Now we do our shade norm. Now we do our shade norm. So second function, draw. Sorry, second function distribution, right? Yeah, second function distribution, draw, shade norm, the smallest, what's the leftmost bound? What's the smallest z-score? 1.5 in this region, I mean, sorry, in the shaded region. It's 1.5. I'm going to shade from 1.5 all the way to 5.
Oh, I hit 5 for 1.5.
Okay? It should look like that.
Oh, while I'm upstairs.
Hang on. Can I,
Yes, go ahead.
please?
I have a question.
Yeah.
If you go -5 to 1 point something 5, is there a way that you can find the blank area?
Yeah, good question. Really good question. Let me just cut and paste this here first. Okay? Oh, I should do the shade norm, I guess. Roland wants to know what happens if you sort of mess up, right?
Well, like if I did it before one of those, like building that
Yeah.
left side.
Yeah.
But if you just go 1%.
Yep. Absolutely. Roland wants to know what would happen if I accidentally went, oh, I got to clear my drawing out here. Guys, just give me like a few more minutes, okay? Well, Ryan is asking, what if I do my shade norm backwards? So he's going shade norm -5 to 1.5, right? Is that what you're saying, Rowan?
Yeah.
Okay. So if you do that, well, then what you're doing is you're shading the opposite, like so, right? Here the answer is 0.93, right? I got to take a screen capture there. Here the answer is 0.93. What was the answer before? When we did it the proper way, it's 0.06. These two numbers, Rowan, should add up to 100%, right? So it would be 100 minus 6.7, right? This one is 93.3. Okay? So what percent, the answer to the question is, what percent of Cabernet Meunier bags are greater than 45 grams? And your answer is 6.7%. 6.7%. I'm going to repeat the steps again. Convert the raw score, convert the raw score to a z-score, draw the curve, figure out your shade norms, set your window, shade norm, there's your answer. Okay? I got a feeling we should probably do one more.
That's practice experiment. Mine came out to -0.0681.
I'll come by in a second.
It's the same number. Hey, you can't use that word. Take it back. I didn't sign that sheet. I can use the word I want. I didn't sign that sheet either. Just out of respect.
I'm going to say let's do number 120, page 124, page 124, number 2. I'm just going to ignore these. Page 124, number 2. Okay? Give that a go.